Question number 3, a solid bar has a square cross section. A solid bar. Now we are talking about a three-dimensional bar over here. It's like this, like this. It has a square cross section. Okay. And then its length is measured to be 50 plus or minus 0.2. This is your L0, this is your delta L0. And its width is measured as 2 into 2 plus or minus 0.01, which means what? This is 2 centimeter, this is 50 centimeter, and there is an uncertainty given. These values are used to calculate the volume of the bar. What is the percentage uncertainty in the calculated volume? So now, volume, how do you measure here? This is nothing but length multiplied by area. Okay, what is the area here? Area here, let us say for example, if this length, okay, is something like A here, and this is also A here because it's square. So I can now write L into A square over here. Okay, so now let us calculate delta V by V, which should be delta L by L plus 2 times delta A divided by A. Okay, when I do this, so what is the answer I get over here? So I'll be getting delta L by L. What's the value of delta L by L? Delta L is 0.2, L is 50. I'll substitute this 0.2 divided by 50 plus delta A. Delta A is 0.01 divided by 2. 2 multiplied by 0.01 divided by 2. Am I right? 0.01 divided by 2. Okay. So many of you have a question like, will you have a plus or minus here? Why am I not putting this value? I will just take the absolute value over here. This plus or minus means something here. You can tell about the range over here. Here that is not required. Okay. So now when I do this, what do I get over here? So this would be, let me use my calculator. Just a moment. Okay. So 0.2 divided by 50 would be 0.004. 0.004 plus this will be 2 and 2 goes away. We get 0.01, which should now be equal to 0.014. Okay, and if I multiply, this is what is this? This is relative uncertainty. If I multiply this by 100, what do I get here? I get this as 1.4%. This is the right answer, plus or minus 1.4%. D is the right answer.